Exercise 183, page 462, question 7. B, part A is quite straightforward, so I hope we should be able to do that one. But part B, just a little bit more complex. Of course, think of the 2 over 3 can again come outside. So this would be 2/3 integral between -1 and 2. The e to 2x is underneath, so that's 1 over e to the 2x dx. So that step, the 3 can come out, which is underneath 2/3, and then 1 over e to the 2x inside. Now, of course, 1 over e to the 2x is the inverse. So I've got to think of this as 2/3 times the integral between -1 and 2 of e to the -2x dx. Now, when we perform the integral here, the -2 comes out and goes underneath, but the power stays the same. So this becomes 2/3 times the -2, -1 over 2, e to the -2x between -1 and 2. The -2 comes out and goes underneath, so I've got -2 underneath, which is effectively -1/2. The -1/2 can come outside the integral, so this becomes 2/3 times -1 over 2, and then inside we've got e to the -2x, which is 1 over e to the 2x between -1 and 2. Well, the 2's cancel, leaving -1/3 times 1 over e to the 2x between -1 and 2. And now we put the limits in, x equals 2 and x equals -1. So this becomes -1/3, 1 over e to the 2 times 2 is 4, minus 1 over e to the -2. And we can put those into the calculator and get out the correct answer. But thinking of this, maybe algebraically, just taking it a little bit further, 1 over e to the 4. Now, minus, this is an inverse of an inverse, effectively, which actually just tells us that it's e squared. 1 over e squared is e squared. 1 over e squared. Effectively, if you think about when you divide by a fraction, you invert and multiply. So that's this bottom bit inverts and multiplies, so this becomes 1 times e squared over 1, which is just e squared. So that's where that comes from, which is a slightly simpler form. Again, calculate that out and you should get the answer in the text.